All right, this is me going through the study guide. Those of you in class that wish to completely ignore this, you may, but I am recording this so that we have it accessed for later. The first two questions are when we talked about the sum of the weighted parts equals the whole. So in this case, when we have 8, 3, and 4, we know that we can say 8x plus 3x plus 4x equals the whole. Since these are measures within a triangle, we know the whole is 180 degrees. That gives us 15x equals 180, divide by 15, and we get x is equal to 12. But that's not the end of it because it asks for the measures of the angles. So one of the angle measures would be 8 times 12 equals 96 degrees. One of the angles would be 3 times 12 equals 36 degrees. And one of the angles would be 4 times 12 equals 48 degrees. That's truly the answer to the question. Next one, similar problem. Again, it's the weighted sums. So we'd say 9x plus 12x plus 5x equals, what's the total? Well, these are sides in that proportion, and we're looking at the perimeter. So the sum of all the sides would equal 130. So this would be 26x equals 130. When I divide by 26, I get x equals 5. But again, we're looking for the measures of the sides. So we would say the 9 ratio piece is 45 feet. The 12 times 5 would equal 60 feet. And the 5 times 5 would equal 25 feet. Those are 3 lengths of my sides. Problem number 3. Find the scale factor from figure A to figure B. Okay, so we want to go from A to B. That means I need to pick some side from this and set it up as a ratio with the corresponding side from here. It's not the best worded problem because we don't have the third side. We can't be certain and we're forced to look at the picture, but we do know that 25.2 seems smaller than 36, while 14 is smaller than 20. So those should line up. And 36 is the larger, and 20 is the larger. So I get to pick whichever pair I want to find the scale factor. I'm going to go A to B. I'm going to choose 36 to the corresponding B value of 20. And I can reduce this. This is 9 times 4, and this is 5 times 4. So it's 9 to 5. That's okay. Often scale factor would be written as a fraction, like 9 over 5. Same type of problem for number 4. This time we're going B to A. So I just need to pick corresponding parts. So I'm going to go for the smallest number. 12 is the smallest number on this side, and 9 is the smallest number here. So I may as well just use those. I'm going from B to A, so 9 to 12. This is 3 times 3, this is 3 times 4, so I can reduce it to say 3 to 4. And again, as a fraction, I can say that the scale factor is 3/4. Number 5. It tells us that these two triangles are similar. And if they're similar, then we know that corresponding sides are proportional. But this time I don't have values, I have variables. So how do I know which is the small and the larger one? Well, I really don't. But because I was given a similarity statement, I know that KL is going to line up with VW. So this side corresponds to this side. And KJ corresponds to VU. So those two line up. So I can set a proportion that way. I can say 25 is to 20 as 4x minus 23 is to 2x plus 2. How do I know this goes this on top, this on the bottom? Well, remember that horizontally they have to have something in common. They do, they're part of this picture. Horizontally, these have something in common. Vertically, they have to have something in common. These are the corresponding parts by the similarity statement, and so do these by the corresponding parts. Now I can do my cross multiplication. Say 25 times 2x plus 2 is equal to 20 times 4x minus 23. I can I can distribute and get 50x plus 50 equals 80x minus 460. I'm going to try to keep my x's positive, so I'm going to subtract the 50x from both sides. I get 50 is equal to 30x minus 460. I can add 460 to both sides to get 510 equals 30x. Divide by 30, divide by 30. Zeros cancel, 3 goes into 51 17 times. So x equals 17. Find the value of x. I did. Problem number 6. Similar problem. I've got, get it? See what I did there? Similar triangles, and I'm finding the value of x. So I need to line up parts. Well, ML is the last 2 digits here. So RL should match. Here's ML, here's RL. So those two line up. And then NL and SL should match. So there's NL and there's SL. Okay, so 28 over 24 should equal 3x minus 1 over x plus 7. Now that I've got a proportion, I can cross multiply to solve. So 28 times x plus 7 equals 24 times 3x minus 1. Distribute 28x plus 7 times 28 equals 196 equals 72x minus 24. This time I'm not going to keep the x's positive. I'm going to just put it where I want it, over on the left side if it looks right to me. Negative 44x, and then I'll subtract, and I get equals negative 220, and I divide by negative 44, and I get x equals 5. Find the value of x. That's what I did. Two similar problems. I'm given the triangles are similar. That gives me my similarity statement. So ED or DE has to match up with JK. And EF has to match up with KL. So 10 is to 25 as x plus 11 is to 6x plus 3. Using cross multiplication, I can say that 10 times 6x plus 3 equals 25 times x plus 11. So 60x plus 30 equals 25x plus 275. I'll subtract 25x to get 35x plus 30 equals 275. Subtract 30, 35x equals 245. 245 divided by 35, x equals 7. But this time we're not over there. It wants us to find KL. KL is 6x plus 3, and we just found x is 7, so KL equals 6 times 7 plus 3, which means KL is 42 plus 3, so So KL is equal to 45. Number 8, it's a very similar problem. This one has a lot of opportunity to get mixed up with the ratios. So make sure to pay attention to the similarity statement. It says that PQ, well, that doesn't help me at all. How about RQ? So RQ is going to match with SR. So here's RQ. SR is over here. This thing's catty-womp. PR is those two. RT is those two. So we start off with 2x minus 1 is to 38 as, let's see, 2x, these are in the same triangle, so those are the ones that have to line up together. And 38 and 60 are in the same triangle. Now to solve those, I have to get it cross multiplied. I'm going to say 60 times something equals, so 60 times 2x minus 1 is equal to 38 times 4x minus 26. So 60 times 2x is 120x minus 60 equals 38 times 4 is 152x minus 26 times 38, 988. Now let's keep the x's positive. I'll subtract 120 from both sides. Negative 60 equals 32x minus 988. Add 988 to both sides, and I end up with 928 equals 32x. Divide by 32, and I get x equals 29. But I'm not quite done because it wants me to find SR. So I know that SR equals 2x minus 1. So that means 2 times what our new x value is, 29 minus 1, which is 58, minus 1, which is 57. It's very strange to not ask if you have questions. I guess there's not a way to do that right now. Got two triangles similar. Got some components here, so let's figure out what we've got. Well, this KF is a big one, so let's make that work. Here's KF. That should line up with ZF. And KF has to line up with ZF. Okay, so those are both 4. Those are both green. And then I also need to have, what do we have here? This L is a little bit off place. That belongs over there, I think. So LF, which is these two, should line up with NF, this whole length, which is 15 plus x plus 3, or x plus 18. So that's NF. All right, so let's set this up. KF, which is x plus 3, over ZF, which is 4, should equal NF, x plus 18, over LF, which is x plus 3. Ooh, we're going to get a quadratic here. So cross multiplying, I'm going to get x plus 3 times x plus 3 equals 4 times x plus 18. So x plus 3 times x plus 3. X times x is x squared plus 3x plus another 3x plus 9. And this is 4x plus 36, 72. So this cleans up to x squared plus 6x plus 9 equals 4x plus 72. And because this one's quadratic, we don't want to put the x's on one side and the constants or the numbers on the other side. Instead, we need to get this all equal to 0. So I'm going to subtract 4x from both sides, leaving just 2x. And I'm going to subtract 72 from both sides, leaving minus 63 equals 0. And the goal here is to express this as a product. Right now it's a sum or difference, x squared plus 2x minus 63. I need to express it as a product of two terms. So we've got a little process for doing this. Let's make some room here for this. I'm going to start off by using the diamond, which helps me figure out what these terms have to break into. So on top, I put the product of this coefficient, 1 in this case, and negative 63. And on the bottom, I put the coefficient of the x term. Now, I need to find two numbers that multiply to make 63, and yet add to make 2. The fact that 63 is a negative number means one's going to be positive, one's going to be negative. And when they add together, then that's really going to be a difference, because you got an addition and a subtraction together offsets each other. So I'm thinking about all the factors of 63. I'm looking to see if there are differences too. 63 times 1, that difference is 62. That's not there. 2 doesn't go into it. 3 goes into it. 21, that's only a difference of 18. That doesn't help. 4 goes into this. No. 5, no. 6, no. 7. Yes, 7 times 9. There we go. There's a difference of 2. So this is the relationship I want. I want to end up with a positive 2, so I'm going to make the bigger one positive. The 9 is positive, and the littler one is negative. And now what I have to do is I'm going to express this, x squared and minus 63 equals 0. I'm taking away this 2x, and I'm replacing it with these two. So I'm going to say minus 7x plus 9x minus 63 equals 0. And then, I should have left more room here. I'm going to take these two terms, the first two, and see what's common to both of them. This is x times x. This is 7 times x. So there's an x common, and I can pull it out, leaving x minus 7. And then I'll do the same thing over here with my 9x minus 63. I want to see what's common to these two terms. Well, this is 9 times x, and this is 9 times 7. So I'm going to pull out a 9, leaving x minus 7. Now, this is a part that's a little weird, but I had two terms here, and I factored what was multiplied in both of them to get this expression. Now I want to visualize this as though, again, I've got two terms. This time, my two terms look much more complicated. One of my terms is x times x plus 7, x minus 7, and one of my terms is 9 times x minus 7. But I'm looking at those two terms and seeing what's common to both of them, x minus 7. So I pull that out, and what I'm left with is x plus 9. That's now the factored form of this quadratic we had. Now, if this times this equals 0, the only way that can happen is if one of these parentheses equals 0. So either x minus 7 equals 0, which means x equals 7, or x plus 9 equals 0, which means x equals negative 9. Algebraically, there are two solutions. But I know that if x is negative 9, when I plug it in here, negative 9 plus 3, the length of LS would be a negative number. That doesn't make any sense. So this particular answer, because of the geometry, is going to get crossed out. That's not relevant for our problem. We found the value of x, it's equal to 7, but really they're asking us for NF. In other words, this length. Well, we said that's x plus 18, and f equals x plus 18, which means NF equals 7 plus 18, because we found x is 7. So NF equals 25. That's a pretty meaty problem. Number 10, triangles are similar with a scale factor of 4 to 3. Okay, so because of the way they phrased it, this one is 4, this one is 3. What that means is any length, like if I knew that CD and WX were corresponding, that whatever this is would be in the ratio of 4, while this is in the ratio of 3. But rather than find all three sides and add them up, we also learned, remember when we did the LR and the AR? We talked about the length ratio and the area ratio, where the length ratio is A over B and the area ratio is A squared over B squared. What we talked about is the length ratio is consistent for sides, for altitudes, and for perimeter. So if we know that the ratio, the LR, is 4 to 3, then we know that's also true to the perimeter of CDE over the perimeter of WXY. So we know that 4 to 3 is equal to, what's the perimeter here? 13 plus 29 plus 22. So this is 10, 20, 30, 40, 50, 62, 64. So this is 64. And what we're being asked to find is the perimeter of that. So I'm going to call that X. Now it's a proportion I can solve. 4 times X equals 3 times 64. 3 times 64 is 180, 192. Yes. So 4X equals 192. Divide by 4. X equals 48. That's the perimeter of WXY. Okay, so now we're determining if these triangles are similar. If yes, state how. So these are our three theorems: angle-angle similarity, side-side-side similarity, or side-angle-side. In this problem, I see that I've got an angle congruent because of vertical angles. And now I need to see if these are in the right proportion. So how do I know these match up, or these? Well, I'm going to do the same thing I've done previously with the sizes. 15 is the smaller of the two. 21 is the smaller of the two. This is the larger, this is the larger. So that should be my proportion. 15 over 21. 15 and 28 match up. 28, so they're lined up on top, and 39.2 matches 21. So if in fact these sides are proportional and this angle's congruent, then we can say by side angle side similarity. Let's see. 15 times 39.2 equals 21 times 28. Time for a calculator. 39.2 comes out to be 588. And 21 times 28 is also 588. Excellent. So that gives me two S's, right? Two pairs of sides that are proportional. And I had this angle that was congruent. So that gives me side angle side similarity. PKM. So this was at the end of the green, down the blank side. So at the end of the green, so triangle L down the blank side, QM. Number 12. Well, I don't see any side lengths, so if this is going to work, it's by angle-angle similarity. I'm going to find this angle, and if I can find that angle to be 98, then I know that these corresponding angles are congruent. They share this angle, and the third angle would have to be congruent by the corollary to the triangle angle sum, and that worked beautifully. So I'm going to call this X for now. I'm going to say X plus 47 plus 38 has to equal 180 because this makes a triangle. So X plus 70, 85 equals 180, subtract 85, X is 95. Oops, it was supposed to be 98. So therefore, these angles are not congruent. Since angles not congruent, triangles not similar. Moving on. Number 13, we're continuing with the same style of problem. So we're trying to decide if these triangles are similar. In this case, we've got 3 pairs of sides. So we have to see if all the matching parts are proportional. So I'll choose the smallest side here, 8, 9, 12, and compare that to 10, because that's the smallest here. The mediumest is 9, which means this one is medium. This one's small. And the biggest and the biggest. So all those ratios should be consistent. Let's pick one pair. We'll do the purple and the blue. So we would say that 8 to 10 should equal 9 to 11.25. So that would mean that 8 times 11.25 should equal 10 times 9. 88 and 2 is 90 equals 90. Okay, that's good. That gets us 2 of the S's. The purple and the blue are the same. Now we got to get the red in play. So 12 over 15 equals, I don't have a new matching set there, but that's right. I don't need a new one. I need to use either of these. I can use the 9 and 11.25, or I can use the 8 and the 10. I'm going to choose the 8 and the 10 because they're whole numbers. And I know that 12 times 10 equals 8 times 15. This is 120 equals 120. That works. That gives me my third side to say that these two triangles are similar by side, side, side similarity. What should the similarity statement be? RYN. Okay, so they started on R, which is between purple and blue. Purple and blue. So we have to start with A, RYN. So it went along purple. So from A we go along purple, so we go D, E. Number 14, let's see. Well, we know that these angles are congruent because of vertical angles. And since these lines are parallel and this is a transversal, we know that this angle and this angle are congruent by AIA. So that gives me enough. That lets me say that they're similar by angle similarity. And what that means is that PAS, so let's see, P is the one that I didn't mark as congruent, going to the double blue. So that would be FAC. Okay, number 15. Well, we've got an angle pair, and now we've got 2 sides. So it looks like it's leading towards SAS. I'll take the smaller one of these and the smaller one of these. Those should match up, and the bigger should match up. So let's see. 30 is to 44 as 32 is to 48. So we should see that 30 times 48 equals 44 times 32. So 30 times 48 is 1440. Ooh, so we get 1440. I could have known that because 0 times 8 leaves a 0, and this is going to end in an 8, 1408. Those are not the same. Since the sides are not proportional, we're going to say not similar. All right, number 16. I want all my pieces to match. I've got an 8 and a 9, those match up. I've got a 32 that's just this little chunk, and then I got this 45 that's too long. So I'm going to find this chunk here. If that part's 9, and 45 minus 9 makes this 36. And so what I expect is these two and these two will be proportional. So 32 is to 36 as 8 is to 9. Could I have done it as 32 is to 8 as 36 is to 9? Yep. Either would work. Regardless, I'm going to get 8 times 36 should equal 9 times 32. Excuse me. All right, so 8 times 36 and 9 times 32, both equal to 288. Excuse me. That works. So that gives me 2 sets of sides. I don't have a third. They've got this shared angle. So my side, angle, side, similarity, they are similar. And now my similarity statement, JKN would be RVN. Okay, I only assigned one proof this time. This is the proof. For those of you in class, if you want to watch this, this is the only proof, and it's going to be more challenging, I think. It's probably worth watching for a moment. We begin by writing our givens. PS bisects angle RST, that's our given. And we know one other thing. We're trying to prove that triangle STP is similar to triangle SRQ. And we know that, oops, it's off screen. And we know that the only possible reasons here are angle-angle similarity, side-angle-side similarity, or side-side similarity. But still, we have to find our angles and our sides and see if they match. So it tells us that this bisects an angle. What does that mean? Well, if this angle, RST, is bisected, that means that angle RSP is congruent to angle TSP. Why? Because that's the definition of an angle bisector. And that gives me something. That gives me an angle that's congruent, right? This angle is congruent to this one. So now I'm either going to be getting another angle and say it's angle-angle similarity, or I'm going to get 2 sides. Well, let's see what they give us. They give us 1, 2, 3. They give us 2SP equals 3SQ. And I'm just going to write that one there for now. And I'm going to say that if it's sides, these are sides. So if it's sides, I need to get a side ratio, like SQ is to SP or SP is to SQ. I guess since we got SP first, I'll make SP one on top. So I need to divide both sides by S. This was given. So I'm going to divide both sides by SQ, and that's going to leave me SP over SQ, but I don't want the 2 there either. So I'll divide by 2 at the same time. So I'm going to use division, property of equality, to get SP over SQ. In other words, divided this side by SQ and 2. And now I have to divide this side by SQ, canceling that, and by 2, getting me that. Now, I'm actually going to put in the other given at the same time. 2ST equals 3SR, because it's still given, still the same reason, and I still want the division property. I'm going to divide both sides by 2SR. By doing that, this is going to become ST over SR equals 3 over 2. Now that I've got this equals 3 over 2, and this also equals 3 over 2, I can say that these two things are equal because they're both equal to 3 over 2. So that's the substitution property of equality. And what that gives me is 2 pairs of sides, SP and SQ line up, and ST and SR line up. So that gives me a side and another side, which is all I need to prove the triangles are similar by side angle side similarity. All right, problem 20 asks us to solve for x. We might remember that if these 2 lines are parallel, we discovered that it splits the sides proportionally, such that x is to 18, as this unknown portion here is to 21. So the first thing we'll have to do is find that unknown portion, recognizing that if the whole is 28 and this part is 21, that the difference is that piece. So now we can create the proportion. We could say that those two are in the same proportion as these two. So x is to 18 as 7 is to 21. And we can cross multiply. So 21 times x equals 7 times 18. 21x equals 70, and 56 is 126. Divide by 21, divide by 21, x equals 6. It asks for x, we've found x. This is a very similar problem. Again, it's got sides split by parallel lines, suggesting that these two are in the same proportion, and these two are in the same proportion. So x plus 5 over 15 equals 5x plus 1 over 35, which means I can cross multiply and say that 35 times x plus 5 equals 15 times 5x plus 1. Which gets me 35x plus 150, 175 equals 15 times 5 is 75x plus 15. Looks like I've got more x's there, so I'm going to subtract this way. So 75x minus 35 is equal to 40x. Minus 15 is 160. Divide by 40, divide by 40, x equals 4. And yes, we were looking for the value of x. Next one, this is the extension on that. It doesn't even have to be a triangle. If you've got a string of parallel lines cutting across lines, then the proportionality is consistent between those parallel lines. So I can say that 40 is to x as, let's see, what lines up with 40? 40 and 32 are in the same segment, and x and 14 are in the same segment. So this is a valid proportion. So I'd say 32x is equal to 40 times 14. So 32x is equal to 400, 560. Is that right? Yeah. And when I divide that by 32, I get x is equal to 17.5. Same idea here. My lines are split, making these proportional. So 24 is to x plus 6, as 27 is to 2x minus 2. Cross multiply. (24 times 2x minus 2 equals x plus 6 times 27. This is 48x minus 48 equals 27x plus 120, and 42 is 162, I think. 27 times 6. Yes. I'll subtract 27 from both sides, leaving with 21x minus 48 equals 162 minus 48. No, plus 48, so that's 210. Am I boring you, Ms. Betterton?
Oh, sorry.
All right, it's recorded for all posterity. Okay, continuing here. To get redundant, right? We have the same process again and again and again. These sides have been cut proportionally. So 12 is to 3x minus 1 equals x minus 2 to 24. Ah, this one's going to get juicy. Why? Because when I do my cross products, you'll notice that I'm multiplying two binomials together. As a result, this side, 12 times 12 is 144, so this is 288. But this side's going to get a binomial, 3x squared minus 6x minus 1x plus 2. So 288 equals 3x squared minus 7x plus 2. Because this is a quadratic, we don't do the same process as linear. We're not going to subtract 2 from both sides, get the numbers on one side, the x's on the other. Instead, we're going to subtract the 288. We want to get it set equal to 0. So that's minus 286. Whew, big one. And now we need to factor this. Factoring this process can take some time, because what we're going to try to do is on the top of this little x, we're going to have 3 times 286. So we're going to have negative 858 on top here, and we need that to factor with a difference of 7. So how do we do that? So the challenge is, how do I factor this huge number, 858, down to make negative 7? Well, the easiest way, make a little space over here, is for me to take the number 858 and factor it. Well, I know it's an even number, so I'll divide it by 2, and I get 2 times 429. 6 and 9 is 15, so I can get a 3 out of this. 3 times 143, and that's a weird number. That's 11 times 13. You might not have known that. You might have had to guess for a while. But the trick is, I want to take these 4 numbers and combine them in such a way that they're 7 apart from each other, right? In other words, if I do 3 times 11 times 33, 3 times 11 times 33, it's true that, no, excuse me, 3 times 11 times 13, it's true that 429 times 2 works, but that's way too far apart. So I need my numbers to be kind of close together. So among my 2 bigger values, 11 and 13, I'm going to multiply the 11 times the 2 and the 13 times the 3. So would 22 and 39 work? No, that's 17 apart. That's too far. What about 11 times 3 is 33, and 2 times 13 is 26. 33 times 26 is 858, and they're only 7 apart. That's what I want. So I'm going to put my 33 here and my 26 here, and I want a negative 7. So I want the bigger one to be a negative, and this one's positive. So what this tells me then is I need to take this expression, and instead of negative 7x, I'm going to split that up into these parts. Negative 33x and plus 26x. Still makes negative 7. I've just broken it up in a very specific way. And now I'm going to do what's called factor by grouping. I'm going to take this part, first 2 terms, and look for what's common to both of them. Well, this is 3 times x times x. This is 3 times 11 times x. So there's a 3x I can pull out of both parts, leaving me with x minus 11. And then I'll do the same thing over here. I'm going to take these 2 terms and see what comes out. And if it works, what's on the inside is always going to be the same thing as what was on the inside here. So that gives me a little hint. If I want to pull this out, I should divide by 26. Does 286 divide by 26 evenly? It sure does. X minus 11, if I pull a 26 out front. This is all still equal to 0. And this next step is the odd step. Just as in here, we took 2 terms, 3x squared minus 33x, and we factored each part into its components and said what's common to both of these parts to pull out the 3x. We're going to do the same thing here. I've now got one term, 3x times x minus 11, it's already factored, and another term, 26 times x minus 11. And what I'm looking for is what's common to both of these 2 parts. Well, there's an x minus 11 as a factor of both of these parts. Therefore, I can say that I can pull out the x minus 11, and what's left then is 3x plus 26. And this is the fully factored form. Since they multiply to make 0, either x minus 11 equals 0, or 3x plus 26 equals 0. If the x minus 11 is equal to 0, then x equals 11. If the 3x plus 26 equals 0, then 3x equals negative 26, so x equals negative 26 thirds. It's close to 9, but it's a negative number. And if I did a negative number minus 2, that would be a larger negative number. Well, I can't have a length of a side be a negative value. So for the geometry, this solution is not valid. Algebra said it is, but for geometry, a length can't be a negative number, so I threw that one out. This is my only solution for x. X is 11. So now we're doing a flip side of this, whereas in these, we said if the lines are parallel, then the sides are cut proportionally. Now we're doing the converse, where we say if the lines are cut proportionally, then these segments must be parallel. So I'm going to take these two, because they're both smaller, right? 6 is smaller than 10, and 15 is smaller than 36. 10 is the bigger one, 36 is the bigger one. So I should be able to validate that 6 to 15 is equal to 10 to 36. And if they work, then I'm going to get parallel lines. Well, I can tell right off the bat it's not going to work, because by multiplying by 10, this one's going to end up with a 0. And 6 times 36 is not going to end in a 0. It's going to be 216. So these are not congruent. They're not equal, which means if these sides are not split proportionally, DE is not parallel to AC. Let's look at it over here. All right, well, I've got 16.1 and 28 matched up, so they're okay. These two are matched up, but what I'm missing is this over here. So I need to do the subtraction again. 64 minus 28 is 36. So this chunk is 36. And I'm saying that this proportionality and this proportionality should be the same if the lines are parallel. Let's see if it is. So I'm saying that 16.1 times 36 should equal 20.7 times 28. It's supposed to be in red. And let's see, 16.1 times 36 is equal to 579.6. Does that equal 20.7 times 28? 579.6. Therefore, since the sides are cut proportionally, we can say that DE is parallel to AC. Where's this is no. Right. Last page. Here they tell us the triangles are similar, and we're supposed to solve for x. These are not my favorite problems because we really don't know that 35 and 42 are aligned and are corresponding. They would have to give us the triangle similarity statement to know with certainty. You can expect on the quiz of the test it is better written than this where it's explicit, but I think we have to just assume that these are altitudes, right? 24 and x are altitudes, and they must be in the same ratio as a pair of matching sides. So these sides must be matching. 35 and 42 would be the same as x and 24. Their ratio would be the same. So 42x equals 35 times 24. 42x equals 840. Divide by 42, divide by 42, x equals 20. We're solving for x, yep. Same idea here. These, because they're going to the midpoint of the side, these are called medians. And that's true that the medians are in the same proportionality as a pair of corresponding sides. So we could say that this median is to this median as this side is to its corresponding side. So 16x equals 11 times 28.8. So 16x equals 316.8. X equals 19.8. Solving for x, found x, yes. All right. Now we're given better information. Now we know that these triangles are similar. So we know that, for instance, here's PQ. It's the first two letters there. So that should match up with HE. HE, this one. And this one is QS, which is angle bisectors. Okay, so these are the same and these are the same. And angle bisectors do split proportionally. So we would expect 7x minus 10 to 3x plus 5 to equal what lines up with this 7x minus 10, same triangle, so that would be 48 and 32. These are going to get into big numbers again, but this time at least they won't be quadratic. So 32 times 7 is 210, 224. Minus 320 equals 48 times 3, 144. Yeah, 144x plus 240. So we'll subtract the 44 from both sides, x's, and we're going to get 80x. Add 320 to both sides, and we'll get 560, which means x equals 7. This time it doesn't stop there. It doesn't say just find x. It says find the value of PQ. Well, PQ is 7x minus 10. So that means that PQ is now 7 times the value of x that we've already found, 7. So it's 49 minus 10, which is 39. Lastly, these are those topics that I just expressed a few minutes ago in the beginning of class. In the event that you have angle bisectors, it turns out that the length of these sides are in the same proportion as the way you split this end cap. So let's first find this other piece here. If this is 18, we know that this side is 16. And what we're saying is that this ratio will be the same as this ratio. In other words, 40 to 16 is equal to x over 18. Cross multiply, 16x equals 40 times 18. So x equals, what is 40 times 18? 720 divided by 16, which is x equals 45. Something for x, yep. Same idea here. If this is x and this is 9, then we know that this part, when added to 9, makes x. So this part is x minus 9. And again, these two will be in the same proportion as these two. So 22.5 is to 9, as 25 is to x minus 9. Cross multiply, and I get 22.5 equals 9, x minus 9, 25. So 22.5x minus 9 times 20.5 is equal to 202.5. 9 times 25 is equal to 225. Add this to both sides, 22.5x equals 427.5 divided by 22.5, x equals 19. And yet we're looking for x. Lastly, this is going to be a bigger one. You can tell because it's a bigger space, but it's the same idea. These two are in the same proportion as these two because this angle is bisected. So 12 is to x minus 7 as x plus 4 is to 15. Oh, I mean, yay, it's a quadratic. So 12 times 15 equals x minus 7 times x plus 4. So 12 times 15 is going to be 180 equals x squared plus 4x minus 7x minus 28. 180 equals x squared minus 3x minus 28. Subtract this over and we get 0 equals x squared minus 3x minus 208. All right, same idea. We have to figure out what the factors are of 208. So I know 4 goes into that. That's going to go in 52 times. This is 4 and 13. I'm looking for a difference of 3. Oh, that's evident to me. 4 times 4 is 16. And 13 and 16 are just 3 away. So I'm going to change this into x squared minus 16x and plus 13x minus 208. And then I'm going to do some factor by grouping. In here, I see that I can pull out an x, so x minus 16. And in here, I can pull out a 13. I knew that 13 times 16 makes 208. And then there's an x minus 16 in both of these, so I can pull that out. What you're left with then is x plus 13. All right, so either this is equal to 0 or this is equal to 0. If x minus 16 equals 0, x is equal to 16. If x plus 13 is equal to 0, x equals negative 13. Again, it's a valid solution in the algebra, but when I come over here and put a negative 13 in plus 4, that gives me a solution of negative 9, which doesn't work. So this one has to get crossed out. This answer is not valid. That's my only solution. The question asks me to find the perimeter. So my perimeter equals 12 plus x plus 4 plus 15 plus x minus 7. I'm going to clean it up first and then substitute. So 12 and 16 and 15 is 31, minus 7 is 24. So it's 24 plus x plus another x plus 2x. We know that x is equal to 16, so the perimeter would be 24 plus 2 times 16, which is 32. So 24 plus 32 equals 56. That's my perimeter. That's the end of the review.